The universe is filled with many mysteries and wonders, many unanswered questions, many mind-boggling discoveries. The vastness of the universe is incomprehensible to the human mind. But what about the things that we do know? Or at least we think we know? Imagine an object that cannot be seen, but we know it is there, just because of its colossal influence on matter around it. Something so black because it does not reflect or emit light. Something in the night sky. Something that is probably watching us. Something like a black hole. What is a black hole? A black hole is a region in space where the force of gravity is so strong that even light cannot escape. One of the most captivating objects found in the universe. The strong gravitational force occurs because matter has been compressed into a tiny space. Imagine a star 10 times more massive than the Sun, squeezed into a sphere approximately the diameter of a city. The gravitational pull from the massive star is now concentrated within this tiny sphere, creating an unbeatable force, absorbing everything around it. When a large star that is 10 times larger than the Sun collapses under its own gravity after running out of nuclear fuel, it causes a supernova explosion. The remnant of a supernova is a black hole. The black hole's mass and size determines its type. There are two types of black holes: stellar black holes and supermassive black holes. The stellar black holes are the most common type of medium-sized black holes. The mass of a stellar black hole can be up to 20 times greater than the mass of the Sun and can fit inside a sphere with a diameter of about 16 kilometers or 10 miles. The largest black holes are called supermassive black holes. These black holes are millions or even billion times as massive as the Sun and would fit inside a ball with a diameter of about the size of the solar system. Scientific evidence suggests that very large galaxies contain a supermassive black hole in its center. The supermassive black hole at the center of the Milky Way is called Sagittarius A. It has a mass that is equal to about 4 million suns and would fit inside a ball with a diameter about the size of the Sun. Scientists are not certain how such large black holes are formed, but they could be the outcome of hundreds or thousands of tiny black holes merging together. Large gas clouds could also be responsible as they collapse together and rapidly gain mass. A third possibility is the collapse of a stellar cluster, a group of stars all falling together in the center of a galaxy, creating a supermassive black hole. The event horizon of a black hole is the boundary around the mouth of the black hole where light loses its ability to escape. Gravity is constant across the event horizon. Once a particle crosses the event horizon, it cannot leave. The inner region of a black hole, where its mass lies, is known as its singularity, the single point in space-time where the mass of the black hole is concentrated. Under the classical mechanics of physics, nothing can escape from a black hole. However, under quantum mechanics, for every particle, there is an antiparticle, a particle with the same mass and opposite electric charge. When they meet, particle-antiparticle pairs can annihilate one another. If a particle-antiparticle pair is created just beyond the reach of the event horizon of a black hole, it is possible to have one drawn into the black hole itself while the other is ejected. The result is that the event horizon of the black hole has been reduced, and black holes can decay, a process that is rejected under classical mechanics. If black holes can't be seen, how do scientists observe black holes? Scientists cannot directly observe black holes with telescopes that detect X-rays, light, or other forms of electromagnetic radiation. However, scientists can see the effects of its strong gravity on matter around it. If a black hole passes through a cloud of interstellar matter, for example, it will draw matter inward in a process known as accretion. A similar process can occur if a normal star passes close to a black hole. The black hole's gravity can sometimes be strong enough to pull off the outer gases of the star and grow a disk around itself called the accretion disk. As gas from the accretion disk spirals into the black hole, it heats up and emits X-ray that radiates into space, and high-energy light is produced. Occasionally, as matter is drawn towards a black hole, it deflects off the event horizon and is hurled outward. Bright jets of material traveling at near relativistic speeds are created. Although the black hole itself remains unseen, these powerful jets can be viewed from great distances. Will the Sun ever turn into a black hole? The Sun does not have enough mass to collapse into a black hole. In billions of years, when the Sun is nearing the end of its life, it will become a red giant. When it has used the last of its fuel, it will throw off its outer layers and turn into a glowing ring of gas called a planetary nebula. Finally, all that will be left of the Sun is a cooling white dwarf star. Could a black hole consume Earth? Black holes are not vagabonds of the universe and do not travel around space. They obey the laws of gravity just like other objects in space. A black hole would have to be very close to the solar system to affect Earth, which is not likely. If a black hole with the same mass as the Sun were to replace it, Earth would not fall in. The black hole would have the same gravity as the Sun. The planets will still orbit the black hole as they orbit the Sun now. Here are some interesting facts about black holes. Theories suggest that if you fell into a black hole, gravity will stretch you out like spaghetti, though your death will come before you reach singularity. Black holes do not suck matter in. Suction is caused by pulling something into a vacuum, which the massive black hole definitely is not. Instead, objects fall into them. Miniature black holes may have formed immediately after the Big Bang. Rapidly expanding space may have squeezed some regions into tiny, dense black holes less massive than the Sun. Astronomers estimate that there are anywhere from 10 million to a billion stellar black holes, with masses roughly 3 times that of the Sun in the Milky Way. Recent discoveries offer some alluring evidence that black holes have a substantial influence on their neighborhoods, emitting powerful gamma-ray bursts, devouring nearby stars, and stimulating the growth of new stars in some areas while halting others.